Hello everyone, welcome to this presentation from flexibility to manipulation, the slippery slope of AI. Today we'll explore an important issue in explainable artificial intelligence, which is that how the flexibility in evaluation methods can lead to manipulation, and what can we do about it. So let's dive in. So the core problem. Imagine you're a researcher evaluating AI explanation methods. A major challenge is the lack of ground truth. There's no definitive way to measure the correctness of an explanation. Instead, we rely on indirect metrics like faithfulness or robustness. These metrics, however, involve numerous hyperparameters, such as how do we perturb the input data or normalize results. Small changes in these parameters can drastically alter outcomes. This flexibility creates a slippery slope where evaluations become inconsistent and open to manipulation. So, a real world example is one from this paper where they compare XAI methods using two different perturbation methods, uniform noise and blurring. With uniform noise, one method performed the best, but when we switched to blurring, entirely different method topped the rankings. This shows how sensitive evaluation outcomes are to parameter choices, not because the methods changed, but because the evaluation setup did. So I don't have much context on these XAI methods because this is my first class, but yeah, um, what is important here is to understand that XAI methods are very flexible and very easily manipulated. So the researchers identified two core ways how the flexibility is exploited. The first one is intra-manipulation, and then the second one is inter-manipulation. Intra-manipulation is adjusting parameters to artificially boost one's method score, and inter-manipulation is tweaking the parameters to change the comparative rankings of multiple methods. You can think of it like adjusting sports rules mid-game to favor one team over another. And both these forms distort results and undermine trust in XAI evaluations. Key parameters that can be manipulated are the partition size, the perturbation function, and normalization. So, after conducting an experiment, the researchers tested their manipulation strategies across datasets like MNIST, Fashion MNIST, ImageNet, etc. Here's what they found out. Scores can be improved by up to 130% through slight manipulations. Entire rankings of methods could be reversed. Some datasets were more vulnerable, while others were more robust. For example, on MNIST, saliency's score dropped drastically when manipulated parameters were optimized for another method, like the LRP method. So, what do the authors propose in this paper? They propose this rank called mean resilience rank. How this works is that they evaluate methods across many parameter combinations and rank their performance for each combination and then average those rankings. On the right hand side of the slide, you can see the ranking vector that they use, which is the output of their MMR. So this approach identifies methods that perform consistently well across settings, like judging athletes based on multiple events rather than one, similar to the Olympics. How MMR works is that it reduces sensitivity to parameter tweaks, but one major con is that it requires significant computational effort. So moving forward, our final thoughts here are that where do we go from here? The study emphasizes that XAI evaluation is more fragile than previously thought. To improve, we can use multiple evaluation metrics as we talked about. We can report results across parameter ranges. We have to be more transparent about parameter choices, and we have to develop standardized data sets and benchmarks. These steps will help ensure that XAI evaluations are robust, reliable, and trustworthy. A few questions that are worth considering is that how can we standardize XAI evaluations? What other evaluation metrics might be vulnerable? How do we balance flexibility and reliability? And finally, what role should parameter sensitivity play in method selection? Thank you so much for watching. This topic highlights how critical it is to scrutinize not just AI models, but also how we evaluate them. If you have any questions or thoughts, feel free to reach out. Thank you.